Hi, my name is Daniel Soto, and I'm with Challenge 2016, and this is the second math video for Calc 2000. We were assigned two problems for this, and the first one is from Chapter 5, Section 4, number 32. And it is the integral of 1 over 1 plus 4x squared from 0 to 1 over root 3. Okay, now to solve this problem, you need to do a basic u substitution for the x. So you would plug in for 2x for this one. So you would get du over dx is equal to the du over dx is the derivative of u in regards to x, and it will be equal to 2. And you will then plug in for dx, so it would have to be that you have du over 2 is equal to dx, and now you have integral 0 to 1 over root 3 of 1 over 1 plus u squared times du over 2, and this will become 1/2 integral from 0 to 1 over root 3 of 1 over 1 plus u squared du. And this is actually a trig identity. It is the derivative of the arctangent. So let me just put that down right here. Arctan of a variable, let's have u in this case, d over du, the derivative of this, is equal to 1 over 1 plus u squared. And so, since this is the derivative, f prime, then if we take the antiderivative of this, we will get this is the derivative in regards to u, and this is the antiderivative of the derivative, and so you will get the original function, f of u, and that f of u will be equal to arctangent. So now, let me just clear out some space. So now, it is equal to arctangent of u from 0 to 1 over root 3, and there has to be 1/2 at the beginning. 1/2 arctangent. And so we're going to plug in for u. Let's do that here, and let's try to save some space. So this is equal to 2x. So now we have, in a different color for the sake of this not to look like a Christmas tree, 1/2 arctan of 2 over root 3 minus 1/2 arctan of 0. And this is all equal to 0. So the final answer is 1/2 arctangent of 2 over root 3. And this does not simplify down, and you can check that actually in your calculator. It will come out to be half of 49, which is approximately 24.5 degrees. Okay, now on to the next problem, which is from Chapter 5, Section 6, and it's number 101. And it is the integral from -2 to 2 of 2x over 1 plus x squared. This also requires a u substitution. This time it will be 1 plus x squared. So when you take the derivative of u in respect to x, it will be 2x. So now sub in for the dx, so it's du over 2x is equal to dx. And so now we're going to plug in those variables. So we have integral from -2 to 2 of 2x over u times du over 2x. So these x's will cancel out. These two x's will cancel out, and so you're left with integral -2 to 2 of 1 over u du. And this is equal to the natural log of u from -2 to 2. And this is because when you take the natural log of a number, when you take the derivative of a natural log, du of u is equal to 1 over, well, u prime over u. And in this case, u prime is equal to 1. So it is 1 over u, as it is in most cases. When taking the antiderivative, you in most cases will have the 1 over u because it's always a constant on the top. So you would just put the constant at the beginning of the integral. And so now we plug in for the u and the variables. So it's ln of 1 plus x squared from -2 to 2, which is equal to ln of 1 plus 2 squared. I'm taking this slow so that we can see the result that's forming. 1 plus -2 squared. And so this is going to need some more room. I'm going to get rid of this u substitution on the top. Make some more room, some more space. So we'll just continue with what we were doing on the bottom, this time in purple. And so ln natural log of 5 minus natural log of 5. And that is equal to 0. And that is your final answer. And if you, let's try to visualize this, okay? So this is essentially what we are asking for, what we were asked for. From -2 to, this is 1, this is -1. And so we're going to graph this function f of x is equal to 2x over 1 plus x squared. And very basic drawing. So it's right around here, then it will swoop up. It is, well, the point I was trying to make was that they are essentially equal, and that they are, not in my drawing at least. But they are equal when you actually graph it out correctly. And so when you take the area under the curve of both of them, you'll be left with the ln of 5. But since they're in different parts, since they're on different sides of the x-axis, in the x-axis, you have to subtract the two, and so you're left with a 0 as your final result. Let me just, is equal to ln of 5. The area under the curve is. This is also equal to ln of 5. That is the absolute value. That is the absolute value of that number. In actuality, this would be negative, and this would be positive. So when you add the two together, you will end up with a 0 as your answer. anyways, that's how you do those problems.